Well, today we have with us a very distinguished VP of Engineering from Couchbase, Sharon Barr, and he's going to give us an incredibly cool presentation about Couchbase, which is, for those who are not familiar, the Couchbase server is like a combination of Membase and Memcached at this point. It's been revised as of like a month ago, so.
At the high level. I hope by the end of this presentation people will know what it is.
Well, it was until a month ago a compilation of Couchbase, of Membase, CouchDB, and Memcached, and now it's something else.
Plus CouchDB.
Yeah. So now it's something else. But everyone, please welcome Sharon Barr.
Thank you, Eric, and I'm really happy to be here and see so much interest around Couchbase. And my goal today is to get you more exposed to a little bit maybe about what NoSQL is, what kind of problems we're trying to solve, and specifically about Couchbase. So I'm going to give you some background about the space, about the company, and then I'm going to talk more technical about the architecture behind Couchbase, and talk about the next version that is coming to the door. I'll do a lot of demos over here, and hopefully get you guys intrigued about it. So, sorry, I'm going to the end. Why NoSQL in general? And some people are already asking a little bit over here what happens in the last 4 or 5 years, that there was this explosion of data and data growth and data consumption. And I've heard this anecdote already 8 months ago that on the previous year to that 8 months, humanity generated more data than the entire years combined before that. And all of this data needs to live somewhere. And for the lack of better solutions, relational databases were used, but then they start facing a lot of scale problems. And this is why the NoSQL kind of solutions came into life, where they're simpler, they have some assumptions, no transactions, no joins, no schema, and what you get in return is much more around the scale and elasticity. If you look at the traditional interactive software architecture, you have the users that are obviously scaling up and growing infinitely. You have the load balancer, and then you have your application server also scaling out, and then you have your database that has the problem of scaling up. So you got a more powerful and beefier machine, but you got is an increased cost, and your capacity reaches some sort of a limit. And this is where you start adding more sort of sharding solutions, complicating your architecture to deal with that kind of scalability limit. When Couchbase comes into the play, what Couchbase is basically doing, it's converting its database tier to horizontally scaled tier, exactly the same as the application. And you'll see it's very easy to add more nodes to the cluster. It takes one click, and we automatically shard the data under the hood. And what it makes is that your cost is linear and your scalability is linear. And you've seen with many of our customers that this is how they grow. So in essence, Couchbase is a combination of 3 open source projects, Memcached, Membase, and CouchDB. In a nutshell, the history of the company, at least the part that I joined, which was Membase, started by Excel partner. They wanted to build a company behind an ubiquitous open source project. After some research, they chose Memcached. Started building the company around Memcached. 6 months into the project, James Phillips joined the company. And he identified much bigger opportunity in the NoSQL market. So for Memcached, they started the Membase project, which is a key value database speaking Memcached language. So you have persistent replication, failover, all of these capabilities. Data is on disk, safe as a database. And that's sort of the beginning of taking Memcached and a database, combining them into a single solution, while keeping it very simple, and this is how this thing came into life. About a year ago, we merged with Couch1, which is a company used to be behind CouchDB. The goal in mind was to convert Membase from a key value database to a document store database, where your values are not binary objects, but they are rather JSON objects or documents, which gives you much more flexibility. And along the way, we took a lot of the capabilities of CouchDB, like views, indices, cross data center application, and encapsulate them together with the Membase product. So Couchbase is basically the combination of all of these 3. It brings you all the goodness of all of these 3 projects into a single, very easy to manage solution. About the company, I joined about 18 months ago. There were 10 of us. There are almost 60 employees today, growing very, very rapidly. We have hundreds of community deployments till date. A lot of them are of Membase, which is the original product. We have more than 150, from 0 to 150 paying customers in a single year of the existence of the product on the Enterprise Edition. We have over 3,000 nodes deployed in production. Zynga is one of our largest deployments, more than 2,000 nodes of Membase. And we have, and if you look at just a brief of the customers, all sorts of customers from social gaming, the big ones, and ad platforms like AOL, ValueClick, Chamber, MediaMind, social networks. The nice thing about all of this social and ad networks that they like about Couchbase is its elasticity. Usually these solutions, they start, and within a month they can face a scale problem, whether you're ad network or a viral social game. And they start with a 3-node cluster of Couchbase, and if they need more, they just provision more hardware, commodity hardware, and they scale infinitely, basically. There are also, Salesforce online services. Nice thing about the big companies that they help mature the software very rapidly. There is also communication companies, Docomo, both Docomo and Zynga are not only our biggest customers. Docomo is the largest mobile operator in Japan, but there are also investors on the company that believe in that so much. So, very quick, overview about the background of the company. Now, when we build our product, we do everything with 3 things in mind. We call it simple, fast, elastic. By simple, I don't mean a simple solution. I mean a very comprehensive solution that is very, very simple to use. It's simple for download and installation. It's simple for application developers. With the release of Couchbase 1.8, we also released a set of SDKs for all the languages, popular languages, and we keep evolving that. And it's very easy to deploy and to manage. This will be a lot of the demos I'll show down the road. It's very fast, and fast in our world is sub-millisecond and many times microseconds response time. Most of the operations are happening against memory. One of the powerful things about Couchbase is that we have a way of allocating memory for your data, and as long as your working set fits into one, you're guaranteed to get a predictable latency or low latency of your data. And there is a lot of statistic around what we build that helps you understand that you're going to reach a limit or capacity constraints, so you don't reach that and you increase your cluster before you have performance on your website. So it's consistent and it's safe. Safe, I mean, data is durable, it's replicated for failover purposes, and elastic. Again, this is the application tier on right scale, which I'm using for my presentations. In one click, you can actually instantiate a single cluster of 100 nodes on EC2, and everything is connected automatically. Usually 100 nodes is a huge amount of capacity. Most companies don't need that amount. But this is how easy it is to create a cluster. And there is a lot of application and failover technology behind it. I'll talk about it. And there is a lot of alerting and monitoring that helps you understand what's happening with your cluster. One of the problems of this world is basically this is a distributed system part of our world. How do you really know what's going on in a 100-node cluster? And if a node is failing and if some of the data is not accessible, all of this made very, very easy with Couchbase. And there is mobile. The mobile side is interesting. We already have the technology. CouchDB as a database can run on Android and the iPhone. We brought it to a level that it was stable and mature enough. And then we realized the technology is not enough. What we are working right now is to productionize this entire solution. So the power on mobile is that it's not only running on mobile devices, it's more that it's replicating itself to the cloud and back, so you can create a communication between mobile devices to each other and mobile devices to the cloud. To some extent, the world is going to mobile and to the cloud, and we managed to bridge the gap with the technology. And now it's really a point about making it a product that people can use and don't need to develop an entire world around the technology. We're going to do that for you. Any questions so far before I deep dive to technology. Okay, so Couchbase Server, just to relieve some of the confusion, what is Couchbase, what is CouchDB, what we really have today out in production. There are basically two versions of Couchbase. 1.8 that was released 2 weeks ago, and that's sort of a rebranding version of Membase. This is a version that is out there with all of these production deployments. It's a key value database. Under the hood, it's using SQLite engine. What we released with 1.8 is not only rebranding, but this is a comprehensive SDK libraries that makes it much easier to integrate to the database. You can have the best database in the world, but if people cannot use its features, then it's useless. And this is why we invested so much on the SDK world. So that's what exists today. Couchbase 2.0 is a next version that will combine CouchDB and basically we're replacing the SQLite engine with the CouchDB technology. Not as is from the Apache, but we adapted it and changed it a lot. We increased the performance significantly to fit the distributed system model that we are living on. So it will be a document store, it will have views, it will have cross data center application, a lot of other good features around this few big ticket items. So on the architecture, every node on Couchbase 1.8 or 2.0 has two components. It has the data manager and it has the cluster manager. The data manager is a component that stores the data on a single node. It has a few interfaces. It has what we call the mem-capable interface, which talks Memcached for CRUD operations. So sets, gets, and updates are all going through the Memcached protocol. Memcached is basically just the protocol layer. Under that, we have what we call the EP engine, eventually persist engine, that can have multiple APIs. On that 1.8, it's using the implementation of SQLite. On 2.0, it's using the implementation of CouchDB. And when it uses the CouchDB implementation, then there is also a Couch interface that is being used for Couch views, and what used to be the Couch interface for CouchDB. The SDKs that we provide are hiding all of these different interfaces by you get a single interface, and internally we can switch between CouchDB and Memcached APIs until we merge them into a single one. On the cluster manager, which is this is a lot of the additions that Membase brought into the world. We are using LN OTP for the distributed system portion of it. There is basically this component is a component that has a cluster awareness of which components I have, what data lives on each component. There is a topology change, a failover node, or adding or removing nodes. It's decided a rebalance algorithm and basically shuffle the data under the hood without making it completely transparent to the application. This component exposes a REST API, port 8091, which gives everyone the ability to control and view and interact with the cluster. We provide two off-the-shelf tools for that, a command line interface if you want to integrate with that, and a full-blown UI. It's all JavaScript, Ajax, single JavaScript file that basically brings the entire world to your browser and shows you a lot of stuff, but interacting only through this interface. So everything I'm going to demo you, if you want, you can implement the same interfaces yourself, and much more. I mean, we are, basically behind what the capabilities of the API is. So how does this system work? Some people are familiar with the Dynamo model, and some other solutions are using that. We are using a slightly different approach. We have this notion that is called the vBucket or virtual bucket, which is different than the bucket notion, which we'll talk later. Bucket is more like a database. Virtual bucket is like a combination of some keys, and this is based on a consistent hashing. So every key on the system is hashed to a single virtual bucket through its life of the cluster. And then every virtual bucket is mapped to a set of physical servers. The first one on the list is a host or the master, and everything else is replica. And all the operations, read and writes, are happening only against one server on the cluster. And this is how we get the consistency. If you write something and read it, it will always be read from the same point in memory and machine on your cluster. And we don't need to deal with your data is not consistent. whenever there is and the replication side is used for failover. So we replicate all the copy of your data, and if you not fails, what we do is we basically activate the replica, and I'll show that. So a more visual example of what's happening, you have 2 application servers, or 100, as many as you want, 3 nodes in your cluster, and this is your documents on your cluster, and they are distributed evenly through this consistent caching. If you have more than one node, and you have to have more than one node, then we activate the replicas. So every piece of data, every node, and one thing I didn't say, all nodes in the Couchbase cluster are equal. Every node is a master for some pieces of the data and replica for other pieces of the data. So every node can hold some of the virtual buckets. The cluster manager tells it, you have to replicate this data to this node. So server 3 is replica for some of the data and active for other pieces of the data. So all the read-write operations for a given key, for document 5, for example, will always go to server 1. And when I add 2 more nodes to the cluster, what's happening is that we are basically reshuffling the data, or start breaking down the nodes with data and moving these pieces of data to the new nodes. Then we update the clients or the client libraries, SDKs that we have. This can actually sit on the application side, or they can sit also on what we call Moxie, which can sit on the server side. There is much more benefits if it's actually sitting on the client side, because it saves extra hop if needed. And then operation that used to go to document 6, for example, used to go to server 1. After we notify the client, there is a handshake, and these operations will now move to server 5. Now, let's say we have reads and writes happening against server 3, and the server fails. Now, there are 2 approaches. One is manual, one is automatic. Once we identify the server failure, we fail it over. And what we do on a failover, we tell all the other servers that holds the replica pieces of that data on that server, promote your data to become active. We tell the clients, the SDKs, this is a new topology of the cluster. And now accessing this data from the server that failed is going to different sets of servers on the cluster. And this can happen instantly. Usually after you do that, you need to rebalance your cluster again, because at this point the cluster, everything is available, but the cluster is not equally balanced across all the nodes. So let's go to the fun part. Any questions so far?
How do you do the rebalancing after the failure?
Sorry?
How will you do the rebalancing after the failure?
You click a button.
Okay.
There is all APIs in that, but you have to, this is the part where you don't know to do it automatically. There are ways to do it automatically, but it's all APIs.
So it looks like this CouchDB supports the rewrite forms.
Sorry?
The rewrite forms, how many nodes have data specific, and based on rewrite, right? So how many nodes are there in total, how many nodes have to have the data written to
Okay.
before write successful?
No, that's not the model.
Okay.
Yeah, the model is we have only one node that is a master for all the piece of data.
Okay.
That nodes all the writes and reads for that key. Every key has only one node that is active. All the writes and reads are happening against that single node.
So each node has a replica that
Yes.
holds the backup.
Yes.
And this node could be on 2 physical servers, right?
They will be on 2 different physical servers.
So there's so it's basically how many nodes have the data is fixed by your setup, right?
Yeah, I'll show that.
Okay.
So what I'm going to demo you right now is let's start from scratch. What I have here is I instantiate 4 nodes for write scale, and what I'm going to do is open the console for one node and install it from scratch. We have packages for, we have RPMs for CentOS, we have Git packages for Ubuntu, Debian for Ubuntu, setups for Windows, and there is also a Mac package mostly for developers. So let me delete everything. So what I downloaded from the website is this RPM package. It's one for latest build for 2.0. By installing it, it's basically setting it up and instantiating the server. And then I go to a web browser to that server, port 1891, which is a web interface, and I have this setup screen. Going through the setup wizard, I can decide to start a new cluster or join an existing one. It gives me information of how much memory I have on this machine, and that is being used as a memory for every node on this cluster down the road. Next step is, at least for developers, I can instantiate the first bucket or data bucket in the cluster, load it with data so it will make it easier for you to understand what you can do with the data. And this is sort of a game simulator that we have. Third step is to define how many replicas I want to have for my data, to your question. And obviously there is a cost. Every additional replica is more data that you need and more capacity. So you have to size your cluster accordingly. And then you also define how many nodes, how much memory each data bucket can get. So how much memory the default bucket will get on your cluster. The default bucket is basically either a Memcached, which is a caching layer only, or Couchbase, which is the actual database that we talked about. And the default bucket is sort of not authenticated. This is the one that you work with if you don't do anything else on the cluster. So click next. You can put some community information, put some credentials. And what I see over here is my overview screen of the cluster. What do I have here? This basically shows how much memory I have on the cluster, how much disk, how many nodes I have. Right now I have only one, and what are the high-level operations that I have, operations per second with these fetches. I can see the data buckets that I have. A data bucket is sort of a database. On our Notion, it's isolated, it's sort of multi-tenant, and it gives you a lot of information of how many operations per second are happening here, etc. While I'm talking, let me initiate what we call a game simulator that I will talk about soon. It will create a load on the cluster and put a lot of data on it. It'll take a minute to initiate. And while this is initiating, the other setting, just to change one setting over here, on CouchDB there is a notion of auto-compaction. CouchDB is using append-only bit tree, so it means that every operation is written to the head of the bit tree, and later on we need to compact it. So over here we define how soon it will be compact. And, okay, so this is the buckets, and the next step is the server nodes. What I can see over here is how many servers I have in my cluster, and the next thing we're going to do is to add 3 more servers I have already on write scale. So just copy the IP address when the server is running. All I need is to put the IP address of the server, put the password, and the server is, okay, let me see. So what you can see that I have one server that is pending the balance, and let me add also 2 more. And this is a flow that many of the users are using. They start with one server, they get confidence, put a cluster of 3 in production, and as the capacity needs are going, they just add more servers to the cluster. And let me add the 3rd one. I can just put the wrong password. let's see what I have so far. So I started some load on my previous on my game simulator, and what we can see over here, that there is now already load on the cluster. We can see some high-level stats of how many operations per second I have, what types of operations, creates, updates, get, sets, what is my disk write queue. And there is a lot of information over here that tells you, for example, how many vbuckets I have right now in the cluster, what is the resident ratio, how many of my items are actually sitting in memory, what is the cache miss ratio. This is an indication of I'm hitting the disk to bring data from the disk too much, which is an indication of I'm running out of capacity. And this cluster is right now running live, and the game is basically doing some stuff that we'll talk soon about. I'll go back to the server node. I have these two nodes that are pending rebalance. They are not active yet. And by clicking rebalance, the next thing that will happen is you'll start moving data between the active node and these two nodes. If we go back to the statistics, over here I can see that there is high-level statistics that the rebalance takes place. And if I look at the statistics, I can see what's going on. So, for instance, if I look at the vbuckets, I can see it by server. I can see that there is a main server that has 120 vbuckets, and the other two servers are increasing in terms of number of vbuckets. If I go to the items, I can see that one node is holding 130. Now, actually, all nodes have the same number of items in them because a new node that came into life took items from the active node. All of this information is available per server, per cluster, whether you have one node or 100 nodes on your cluster. Another thing that we can see over here is that now from 0 vbuckets on the replica side, I have actually active replica data. Because I have more than one node on my cluster, I enabled the replication for failover purposes. And let me instantiate 4 more nodes on EC2 for write scale. If you have time to provision a 7-node cluster for this data. So this is the statistics that you get about the cluster. Again, helps you understand what's going on in terms of capacity. If I look at the data buckets, I can see a summary of how many hops per second, what's going on again on the cluster. And then there are different kinds of settings that you can define. Automatic failover. If a node fails, we allow only one automatic failover for various reasons. Actually, some experience we learned from talking to Facebook. In that case, they said sometimes it's better to have 10% of your data not available than creating more load on your remaining clusters and bring down your entire cluster. So we are very careful around auto failover, automatic failover. Whenever we identify it, we allow only one, and once it's happening, then an administrator needs to come and say, okay, do I need to add another node to the cluster, or can I actually rebalance it without another node? It's more human operated kind of things. There are sets of alerts you can configure over here. The auto-compaction tells you at which level start compacting your data from CouchDB. And this is some information about the sample bucket. So let me go back to the slides. Let's talk about what we're going to see on this cluster. So the document database, what's happening when
I'm sorry, one second. Could you just go over that automatic failover again?
Yeah, on automatic failover, what's happening is that when we identify a node that is down, you can actually see it on the UI that it becomes red. There are ways that once you see it, the data that is active on that node is not available anymore. So you can do two things. You can manually click failover. So if I go back to this server list, what you can see here next to each node, there is a failover button and there is a remove button. We can either gracefully remove the node and then we just do rebalance where we take all the data from that node and shove it to the rest of the nodes, or we can say this node is down, instead of bringing it to be red, we click failover and we automatically, that's happening instantly, we enable all the vbuckets that are replica on the remaining nodes to become active. We tell that to the clients and the data is now available from the replica. From that point on, that node needs to be taken off of the cluster and maintained or handled, and then you need to rebalance a brand new node to the cluster to get your backup capacity. Make sense?
Is there a way to throttle how fast it rebalances?
So we are working on actually trying to predict that. This is some of the hard problems we're trying to solve. It depends on so many variables, like what is your load, what is your disk speed. EC2 behaves completely different than RAID 10 physical hardware. It depends on how much the data is fragmented to some extent. So what you do see, if you notice when I did the rebalance, there was a progress bar that at least tells you that things are progressing, and you can see that this is happening. It doesn't really matter how fast it happens. What really matters is that during the rebalance life, the data is safe. That if you stop the rebalance, everything is safe. I mean, the cluster is not balanced in terms of how much data you have in every node, but all the data and its replica are safe. So we've seen rebalances that took 12 hours in a heavily loaded system, and it can take, like you've seen over here, 1 minute. By the way, the nodes that you're seeing being pending are the nodes that are coming up through write scale on EC2. The scripts that are coming up are telling it join the cluster, and once I'll have a number forward, I'll just rebalance it, and we can move it. Any other question?
I'm a little bit confused. What's the difference between rebalancer and failover?
So rebalance is a controlled manner of moving data between adding more nodes or removing nodes. It happens where all the nodes are alive. Failover is an operation that should only be clicked when the node is not available. Basically, what will happen if you fail over a live node, there is always data in flight. That data might get lost. Usually when a node is failed over, the node is not active anyways, so it doesn't really help. I have these 4 nodes that are ready over here. So, and the other point that I didn't mention is that right now we started the rebalance. You can see that there are 7 nodes that are rebalanced. And the beautiful part of it is that while rebalance, the application is still active. There is no downtime part over here. All of this happening transparently to the application. There is a handshake at the last bits of the rebalance transition. So we take the data from one bucket, we move it to a new node. While we do this transition, the old node is still active. And on the last bits of that data, there is a handshake with all the clients that tells it this node is no longer active for this data, the other node is active. So you might see a blip of the milliseconds at the end, but throughout the lifetime of rebalance, the application is still up and running. And the rebalance, in this case, done, so it was quite fast. Okay, so let's go back to...
You got one question before.
Oh, sorry.
If a node fails, the data that it's mastered for is not available until you initiate from one of the replica one of the replicas isn't automatically promoted to serve as master for that data, so it's basically not available to the client.
Yeah, the data is not available until you have a click rebalance, or there is an automatic failover feature that is enabled. There is a feature that is coming on the next release, which is called dirty read. So the application can decide for whatever reason that, you know what, I still want to read data from the replicas, even though I know it's dirty. So it's more flexibility for the application developers to know, you know what, this data is not going to be changed anyways, so I might as well read it from a replica. But all of this is sort of under controlled manner. You decide whether the data is consistent or not. Okay, so back to 2.0 and what it means to become a document data store. So the 1.8 family was a key value or binary objects. Everything you do, you have to do on a binary object. On a document store, your binary value becomes a document. In our case, a JSON document, where you can do different operations based on the content of the value. We use the same technology both for the key value case and for the document case. On the key value case, all we use is just an attachment for the CouchDB. And the attachment is the same binary value that we had before. We are adding more sort of reserved headers, so expiration and flags, which are coming from the Memcached API are marked by $. And underscore are sort of the CouchDB header signs. And if it's a CouchDB, then your values is basically a set of key value pairs under the JSON object. Now, the document, being a document is only part of the picture. The real value behind it is that we introduce views and queries. And the way views and queries are working is that there is a view request coming to one server. Every server is building an index of all the data that you are preparing for it. and what happened is that this query is distributed to the entire cluster on a scatter-gather manner. So the request is going to all the nodes are gathering the request of that, from that relevant index, returning it to the node that got the request, and that request is going back to the cluster map, to the application. For those of you who are not familiar with the CouchDB, we took the same notion of what is called the design document. Design document is a special type of document that defines your index. It can have multiple types of views inside it, and under the hood, every design document is mapped to a full index on the disk. So you can have multiple design documents on your cluster, or you can have many design documents with one view on your cluster. Every view will have its own index, and there are different approaches. Every time you change something, you don't need to build your entire index if they are separated, but obviously there is overhead behind every design document. I'll talk about it on the views demo. So on the demo, what I have is basically sort of, it's a game simulator where we have three types of objects. We have players, monsters, and items. Players are fighting monsters, and as they get more points, they can buy more items. A player will have a name, an experience level, a level that he's playing, and how much experience he has, and other information. Item will have the name of the item, and he will have the owner ID, which is the username, the player. And there is a monster, and the monster has a name and all sorts of other information. So what I'll show you right now is an example of how you build a view on this type of data model and how you query it. So go back to this cluster, which is alive, and right now I have two buckets on it. And this is I'll use the one that I installed, so you guys can use it as well if you want to try it out. When I look at the data buckets, I can see documents that belong to this data bucket. If I click on the document, I can see all types of documents, and I can browse them. And this is, for example, an item that is this is an item, and it belongs to Damien, cats. And if I go back to the data buckets, I can see the views of that that are created for that data bucket. On views, there are two notions. There is the notion of a development view, and there is a notion of a production view. Usually what you do is when you develop against a development view that is building the index and a subset of your data, and you can do that obviously on a production cluster. So the iterations are faster, the energy to build the index is much lower, and once you're ready, you promote it. So in this example, I already have two production views. One is called the player list, and the method it uses is basically using a MapReduce functions. The map function is something that you can write yourself on JavaScript. It basically goes through the entire data and filter which data belongs to that index. Over here, the goal was to create a list of all the players. So I can see that on my function, I'm looking for all the items that are type of player. So you can look at the random items over here when I create my map. And I'm looking for, for some reason I only see items. This is a monster. If I click on another one, I have many more items. Okay, I can't randomly find them, but what will happen is that when I create that map, I can ask to see the results. And these results are showing me all the items that are type of player. Now I can extend it and I can say, look, I want to, let's sort of extend the query and say I want to find a specific key. So my index is built on all the users. The user comes in, I want to do a query and get all the information about the given user. So I can specify that the key is equal. And this is sort of a web API, and obviously there is programmatic API to get that. So I'll take all the keys that one, show results. For some reason, actually, let's do something else. We'll do start key and then. item, and all of these filters you can do in real time, and there is a set of things that you can do over here. Now it's getting more interesting, so if I go back to the view and I say, okay, now I want to develop against that view and I want to make changes, I do copy to depth, and let's call it, and now what I'm changing is basically the prefix of the filter. And if I go, now I can see that I have the production view and the development view. Things I can do on the development view is basically edit my query. I didn't have the same buttons over here. So let's say over here that I want to see, for instance, not only the user, but for some reason I don't see, oh, here is play. So I want to see what is the overall experience or the level of the user. So we'll also do different ID, local level. Name. Save. And now I'll run it against the development type subset. Since I don't have a lot of data over here, it might be that the type over here. What else is missing? So now I can see all the users and their level, which is level 2, and the name, and then the report of the key. And another interesting thing I can do over here is I can look at it from the on the descending order, so I can see actually the users are selected. And I can see the user that is the most advanced user. And if I click on my user, Sharon, and let's say I click edit, and give myself level 309, 301, save. Okay, save it. Well, it's the latest build. Well, what would have happened over here is that when I run it, I'm seeing my user at the top of the list. So whenever I'm ready to, let's say I played, I changed the queries, I developed against it, and it's ready, the next step will be to publish the view. And it will tell me that there is already an existing design document with the same name, so that's fine. The process to do that is, and actually, let me skip a stage. When I go back to the player list, before I actually publish it to production, I go to the full cluster data set, and I click Show Results. By clicking Show Results, I basically trigger an index build on the development subset. Whenever the index is built as a production, as a full cluster set, now it's ready to go and being published as a production view. And what that's doing is just doing the replacement of the views I built on my development subset, putting it on production, and there is no impact for the production system. What else I can show you over here? Are there any questions around the views so far?
Can I publish only specific views?
Sorry?
Can I publish only specific views from the development to production?
Yeah, so I'm not repeating the questions. The question was, can I publish only specific views? So what you can publish is always a design document, and as I said, this is a design document, and this design document can have multiple views. So when you publish or when you change one of the views, we are basically building the entire design document. So if you have a view that is changing frequently for whatever reason, you better put it on a separate design document. If you have views that are not changing frequently, they should be on one design document. And then obviously there is more efficiency in terms of disk space in building the index. But if I do once names, what I can see is that now I have another separate views for monsters, and I basically we create a completely different view for that one. And whenever it's ready, I'm basically publishing this one.
just the MapReduce function that's being ran when you try to invoke them, or are they actually physically saved in a different structure?
So the question was, when exactly do we execute the view information, if I understand correctly?
Yeah.
And there are a few ways to do that. If I go back to the view, so if you look at the request parameters that you have, one of the things that you have over here is it's called the stale. So the stale function basically tells you when you want to execute the view. Stale OK means that give me results as soon as possible, and I don't care about building the view. Stale update after means give me the results as fast as you can, and after you give me the results, build the view. And stale equal false means that I want to wait until the view is built. Obviously, if you're using the false, and again, that's the logic of your application, the latency of the view request is going to increase because every time you request something. It depends also on how many updates. It means that if you keep having updates to your system, it means that you need to keep rebuild the index, and view with stale equal false will be very slow because every time you call it, you'll have to wait until the results is, the index is built.
So my second question is, other than MapReduce, what basic operation like filtering group by this
so there is the reduce function. Let me show you quickly what's an example of how that works. So for example, I have a player list, and let's look at all the players. I have three types of reduce functions. Count, which tells me how many items I have on this result. Every time I make a change on the development view, I have to save it before I can execute it. We save it to the design document under the hood. When I run it right now, the first click, by the way, what it did, it triggered the build of the index, so I didn't get any result. The second click, the index build was fast enough. The second click returns the 81 items. There is a way to even have custom reduce functions, but it's a bit risky area because you basically put code that can have impact on performance.
Sorry, my question actually is different, but that's good to know. So my question is, when you want to do any kind of data manipulation or selecting and filtering on the data set, does it always have to be a MapReduce function, or are there any other support for filtering?
So on this release, we only support the MapReduce functions on this JavaScript engine. Down the road, we are talking about having more capabilities, more than even MapReduce, basically giving the ability to put custom code on the server. So you can do sub-value manipulations on the server side and so on, but right now this is a capability.
So basic idea is that you have your data saved and then you design a bunch of views which application you would then use, right?
So we can repeat that?
So it's a general concept that you have a bunch of data in your system, and then you design a bunch of views that the application layer would then use to drive the strings. Yes.
Okay. Any other question? Okay, so let's go to the.
Are there features like triggers, store procedures like that?
So the whole NoSQL world is still at its early stage. The things that you're describing, I think, will come down the road, but right now there is no stored procedures as such, but we are talking about different ways of giving you the ability to put more custom code on the server that will give a similar effect. It's not coming on the early releases yet.
But it's something you imagine will come later.
Yeah, I would say what we call we experiment a little bit with Labrea, where you can actually put custom code on the server and let the server hook up to this code and basically run your stuff over there, but it's not anywhere close to a release right now. I would expect something like that maybe toward the end of this year, but there is no official roadmap for this. Yeah.
Can you build this views programmatically without using this web interface?
Not at this point. The SDKs right now, as far as I recall, are more for querying. The idea is that when you build the views, you want to experiment with the data. It's not something that happening on a program, so to say. And this is why we at least give the APIs for that. But I might be wrong. Let me. I'll check on the website and see maybe afterward I can give you an answer. Okay, so a few more things that are interesting. So we talked a little bit about client SDKs. I want to show you exactly, or in a high level, what it means. So we have SDKs for Java, for .NET, PHP, Ruby, Python. What happening under the hood is that, for example, on the Java side, we have our own API layer. We are using Spy Memcached, which is a ubiquitous Memcached Java client written by Dustin Sally, who is one of our co-founders. And we are using the HTTP CouchDB connection for the view request. And our API is basically hiding this implementation from the users down the road. If you want to change it, the API won't change, but the functionality under the hood will be different. So the implementation will be different. On the code side, what you can see is that it's as simple as you define an array list, put a set of servers, you create a Couchbase client with the server list and the bucket name and the password. For regular sets, CRUD operations, this exists already in 1.8, so you just do sets and gets, and you can do a bulk get and synchronize gets. So there's a whole list of APIs. And on the accessing view on 2.0, you define a get view and you define your design document and the name of the view, as we saw. You have a query, you are creating a query object, and you define if there is a get range API. The get range API is using the start key and the end key values, and then you get an object of results from that. And there is a similar code example. If you go to couchbase.com/develop, you can see the entire SDKs over there. On the next big thing that is coming is what we call cross data center application. So the idea behind that feature, and there is a whole lot that we can do over here, is there are two sort of requirements that we've seen over and over again. One is you want the data to be closer to the user. So you have East Coast and West Coast. Users can sort of travel between East and West, but when they're on the East, you want their data to be available from a caller on the East Coast. When they're traveling to the West, obviously you want their data to be available over there. So you can have two separate callers, clusters on East and West, and by triggering the cross data center application, data will be replicated whenever it's updated in one cluster or the other. Some assumption that makes it easier over here is that you cannot update it immediately at the same place. To do that, the next thing that we'll introduce is more conflict resolutions kind of solutions. What we have today is more naive conflict resolution. Even if that happens, we'll just pick a winner. And that will make the data consistent, but the application will not have the ability to choose which one is the winner. In most cases, for ad networks, even social games, for that purpose, it basically serves that goal. There is also the notion of disaster recovery, so you want all your data on a different part of the world. If something happens to the caller in California, then the one in Virginia comes into life, and yes, there may be a latency to access it, but the data is available. And at the end of the day, you can still write the same document in any region, and this thing will sync. So let me show you how that one looks like. So what I have over here is open another. So I'll start some fake load on this cluster, just loading some items. And what I can see right now is that I have this cluster of 3 nodes. And if you look at the data buckets, there is I'm loading item and creating some activity. And then I'm going to the application tab. And on the application tab, what I'm configuring is a cluster reference, so let's call it West. I need to put the IP address of that cluster, and I have a 4th node. That's my node. Put the administrator, the password. Let me just verify that this is a 4th node. Yeah, that's a 4th node. By clicking save, I basically invite the characters. Yeah, that's this. what I have right now is a definition of a West color, and then I created application option. The idea behind the application is that you configure it one way. If you want a two-way configuration, you just configure it in 2 ways. So right now I'm configuring my one cluster, this cluster, to connect to the West cluster, and I'm telling it to connect to the default bucket. I click verify, and then there is the configuration, making sure that the cluster is alive, that we're aware of it. Click replicate, and I can see that the application will start. If I go to this other cluster, I go to the data buckets, what I can see on the statistics that my item count started growing. There are no operations per second over here, but there is data that is being loaded to this cluster through the replication. Now, if I want a both-way replication, then I need to configure this one and create an East column that will point to the other cluster. This whole technology is basically agnostic to the topology changes. It's sort of aware of the cluster topology. If you fail over a node, if you add nodes to your cluster, it will know that my data. It's basically have the same notion of write on the client. It knows that this data now should go to a different server. The clusters doesn't have to be on the same side. If I go back to this cluster, I can view on my applications that this application is an ongoing one. If I delete it, go back, you can see that basically the application stalled. You can see the flattened line of the application. Yeah, I think I hope that gives you an overview of at least what Couchbase is, how production ready it is, and all the features. And I think we've time for some questions.
Before we move on to Q&A, I just want to first thank everyone for coming, and I want to thank our amazing speaker, Sharon Barr. I want to thank our awesome sponsors, and especially the ladders. If anyone is seeking a career, a new career move, talk to Steve over here. He's seeking out some new employees, I believe, for the ladders. Let's start our Q&A. Yes.
What are the differences between like MongoDB and Couchbase?
$1 million question, especially in New York. Well, I think I can tell you what we are strong at and what we are focusing at right now. What we are building is what we call the production-ready kind of solution. The reason we see so many customers is that they trust the solution. We see a lot of cases where companies started, as I said, with small clusters, and now they get more confidence of this NoSQL in general. They just added more nodes to the cluster. We have 10, 20, 30 nodes on a single cluster on smaller companies, right? In terms of, I think, and again, people are asking us, oh, this is open source, how do we even make money? I think the bottom line over here is that people who are putting this stuff under their software and their business relies on that are actually looking for a solution where there is support behind it. There is a company that is going to stay for a while, there is active and very strong development and QA. And from all of the infrastructure perspective, we are building a $1 billion company. I think we probably have the largest QA team in all the startups our size, and we are investing much more in that. Beside that, I think in terms of the feature side, we are obviously catching up. We are doing it on a different way, and my belief is that all the companies on this space, at the end of the day, will try to meet at the same place. And at the end of the day, it depends, who will gain more trust from the customers, from the users, from the reliability. As soon as we are catching up with the development side and the community, I think from the solution perspective, this is going to be the leader. All the things that you're saying are really, this product is 1 year old, and imagine how fast we moved in a single year in terms of adoption, in terms of customers. So from that perspective, I see the acceleration is far faster than any of the other players.
Is there like standardized migration strategy from structure with schema databases to the NoSQL types?
So in terms of migration, there is let me step back a little bit. On the early days when there was only relational database, people start facing scale problems. One way to solve it is they start putting caching layers in front of the database. So Memcached, for example. Memcached is a key value database, so there was already a transition on the architecture side to move to key value. If you actually went down this path, you're already using a Memcached client, so the migration is almost seamless because our server supports the same protocol. So for Memcached deployments, it's very easy to migrate. From a standard perspective, and I'm not talking even about migration, I'm talking about how to simplify the entire world of NoSQL. We started working on what we call Uncle. It's parallel to SQL, but for the NoSQL world, we call it unstructured query language. The goal is to define a standard over there, and we are partnering with Richard Heap, who is the creator of the SQLite database. And once we have a standard, then everyone can implement their own implementation for all of the solutions. But from developers' perspective, once you have the standard, then it doesn't really matter which database you're using under the hood, because it's the same language. By being the thought leader around that, we also expect to get more awareness of the NoSQL and obviously our solution.
I guess as most of us are developers here, can you talk about how CouchDB can be used from an application development standpoint?
Couchbase?
So it looks like the philosophy is you had to understand your data first and decide how your data should look like, and then write your application layer. It's almost like only a view is on top of it. Right? What are some of the techniques you would say for application developers and work with code?
So by the way, we had CouchConf. I think we had one at New York and Chicago. One of the sessions over there are introduction to document databases, and you know what is a document, what is a design document, what is a document database, how you develop applications against it. I can't say in one sentence of it definitely requires a different mindset in terms of application. There is no relational, there is no foreign keys constraints and stuff like that. Your application needs to be simpler in its interaction to the database, which means that you are sort of loading more logic into the application. Again, when you face scale problems, this is the only way to solve it in an easy manner for the constraints. So except showing you code samples, and that would be a different session. I don't have a short answer for that.
So is all that monitoring data available outside of the console?
Yeah, as I said, there is a REST interface on port 1891, and if you go to that URL, you'll actually see a bunch of JSON data that the UI is taking that and using Ajax and just presenting it in a very nice fashion.
So it's only available through the REST API, not JMX or...
Yeah, right now it's only for the REST API.
Yes. Can you talk a little bit about Couchbase Mobile, about packaging tools and SDKs for mobile development?
I can talk a little bit, not too much, but again, what we are doing right now is we are trying to productionize the technology. The fact that Couchbase or CouchDB is running on iPhone and can replicate to CouchDB is not very useful because you need to develop a whole world of tools around it. So the big thing is really to figure out what is the right problem that we're trying to solve over there. If you want to use the technology and try to build your own stuff around it, you can contact us. This is how we deal with it today. We took off all the mobile solutions from the website until we figure out what is the right product strategy for that. And at the end of the day, it's using basically the couch replication technology. Our goal is to try and maintain compatibility on that couch replication, whether it's a single node or a cluster of nodes, and all of these things are under discussion right now.
When you created the original V bucket, there was an option for Couchbase and Memcached?
Yes.
What's the difference?
Well, since we started with the company behind Memcached, the first thing that we released was the Memcached bucket, which is just Memcached in a packaged, very easy way of deployment. You get a lot of the UI. Well, if you select the Memcached bucket, you see much less statistics. You see statistics that fits Memcached. And there are still users out there that are using Memcached behind various solutions. So it's, in essence, a very simple, nice wrapped Memcached, but it's really, the bulk of the thing is the Couchbase, not Memcached.
Okay, the scalability, I think, is obvious, but what would you, so I'm not interested in a large-scale example, what would you say is the best example of the most sophisticated or complicated application you've built in Membase?
You want examples from live customers? I won't use names, I'm not sure I can, but what we start seeing is that there was one customer who started using it on a completely different way from any other customer, and what they in essence did is they almost deleted all their data every day and put it from scratch. And what we end up doing is optimizing our software, working with this single customer much more for fragmentation issue. What it cost in essence is more fragmentation. I think the standard use case is that it's basically, well,
I guess that would be sort of another question. What do you see as the sort of standard use case for this?
Yeah, actually, maybe there is a user over here that can tell you how they're using it. That would be more interesting from a customer perspective. Do you want to say something?
Yeah, sure. I'm from Innovative, I'm CTO for Innovative. It's a video advertising technology company. We're using Membase for, I say, 6 months now. We needed a very high throughput key value storage to deliver ad tags. So a user goes to CBS and asks to see CSI in New York, and there's an ad that's supposed to be displayed against it. We use Membase in order to deliver an ad call that fetch some kind of a rule-based engine to define which type of ads this specific user needs to see. So it's something that's fairly small payload and very rapid response.
So I can give you a few more examples. I talked about social games and ad networks, but one use case we are working on right now, and there is a lot of use cases on the website, is Tournament TV. Apparently they have this March Madness kind of gambling for the NBA and stuff. And before they used Membase, basically the site was crashing left and right, and they just couldn't find a solution that was stable enough to hold the throughput. And I've seen enough examples of people told us, it just saved my ass in 10 words. Before that, it wasn't scaling. Now it's actually easily handling the load. The application side is basically all over the map, whether it's, again, social applications or TV or just any place you have a scale problem. I can't really say in architecture there is one way of people solving their problems because they have so many opinions on architecture and stuff. Not the best answer, but there is no one answer for that.
All the way in the back. What's the use case in financial markets and the daily variation in financial markets? Is there one?
Again, I don't think, in my opinion, that this NoSQL won't sit behind your money or banks or anything like that anytime soon. For that, we need really the solid relational databases, the slow ones, but there is no, you have another cent on your bank, you don't want to lose it. A lot of the use cases around that will be more around the web applications, the interaction of users with data rather than with their money. But I don't really have an example of specifically how they solved it over
there. Yeah, is there any limitation on a database size or a record size?
On Couchbase, I think the limitation we have today is 20 meg per record size. Arguably there is no limitation, but obviously if you start using very large objects, then there is architecturally there is some flaw because you don't want to send 20 megs over the network every time you want to change 1 bit on your data. The average value size that we're seeing are between 1 to 10K, but it goes as low as 20 bytes for users who are using it for session store, and there are examples of 20 megs some for customers.
And on the replication, does it move the whole record or just the fields that are changed?
Basically, replicate the entire record every time there is a mutation for that record. Down the road, again, we're talking about optimization, that we can only replicate the changes within that record.
A lot of hands.
More of a sort of comment than a question. Somebody asked a question earlier, which was, can you create the view documents programmatically or only through the API? And I would suspect that kind of dovetails in with another question, which was, what do we do about migrating from relational databases? One of the things I see is people starting to build tools which would sort of rip through the current table structures and building these view documents. So one thing you might want to consider is to make some of those, make the ability to create the view documents programmatically available so that people can start building migration toolkits.
Yeah, and one comment on that is usually on relational databases, if you have indices, you also have joins and stuff like that. This thing is not going to be solved anytime soon, in my opinion, NoSQL. I mean, there are still far bigger problems, more land to grab. So,
but if you look at those joins, there's using an application that's taking a particular subset of joins in a particular route to the tables. That could be extracted as a view from the application point of view. But if somebody's got, they might have, say, 10,000 tables and 1 million joins across those tables, but the important applications that they want to migrate might only, say, do, 5,000 views. Nobody's going to do them all by hand, so if you made the ability available, somebody could write a piece of code that actually goes through, looks at the application, and generates those automatically.
Yeah, absolutely. By the way, one thing I actually want to correct myself on the join stuff. There are actually customers that is asking us to implement that. When I say it's not going to be available on NoSQL, it's more on the performance of NoSQL. We're actually thinking about, okay, you want that, it will be obviously a little bit low, higher in latency, but you still have one system that can do that capability.
Yeah, it's probably a bad idea to implement that anyway, because it will kill your performance. I mean, we're essentially going back to the old days of pre-relational databases when databases were hierarchical.
Okay, we've got time for one more question.
Two questions.
Okay, two more questions.
How close is the 2.0 release?
Sorry?
How close is the 2.0 release?
Right now we're targeting for end of Q2.
And in your demo, you use public IPs everywhere. So is the communication between nodes and data centers encrypted by default?
So I worked against EC2. So this is why my demo was over there. The assumption that your database is not running on your front end is still hidden behind your application server. Even on EC2, when you have the right deployment and you have your web server, and then only the web servers can access it. For simplicity, I was using the IP addresses over there, but most of the deployments are, we cannot access our customers' databases unless they give us VPN or they give us the right credentials or EC2.
What cross data center application? Is that encrypted?
Again, the expectation over there that it can either work on a private one. We are talking about right now about more security features around that, whether it's authentication or authorization. It still doesn't exist. I don't have anything to do.
Sharon will be here in the front for one-on-one questions afterwards. And I want to thank everyone for coming, and thank you, Sharon Barr.